Hello everybody, this is Francisco Laboy from Jetmoji. This is a short video explaining the design and proposal for the off-grid energy system to be installed at the Boys and Girls Club in San Juan and the charter school. This is a Google Earth view of the property. I'm actually going around the property. I want to show you some of the characteristics of this, which is very important to understand our design. If you can see here, perhaps the most important is the obstacles that we see. We have several um, wind or air intakes or outtakes, I should say, in the middle, which basically creates shading. Also, we have two buildings, of which each building has each roof has two um, faces, or two sides with a slope or pitch of about 6 degrees or so. So it's not completely flat, but it's not, it's not really mean that the east to west um, variations in the sun would affect the production that much. We have some instructions in the back. We show these trees here. Some of these trees are not there anymore. They were taken out by the storm Maria left about a year ago. So we don't foresee a lot of obstruction shading created by these these trees here. So if we go back, let's just go into the actual design now that we know what we're looking at. This is a CAD view of the building. This here, what we're trying to show here is the radiance map. It's showing you the different locations of each individual solar panel on the roof. We have a 288 solar panel array divided into 12 sections or 12 arrays. And as you can see here, as I move my cursor on top of the building, I can see the irradiance factor. Irradiance is basically the energy that is irradiated into a specific point on Earth. In this particular case, we can see the amount of energy that can be produced in terms of solar power per square meter per year. And as you can see, we have a very, very good irradiance map on top of our building. 1,922 kilowatt hours per square meter per year. That is very, very, very good, considering being in San Juan with the cloud cover, and perhaps the fact that we don't have as much sun as basically as perhaps in the south of the island. So if we look at this in a 3D mode, we're going to get there in a second. I'm going to show you what's called the analimas. The analimas is just yellow lines that you see here. The analima is nothing other than the position of the sun in relation to the to a specific point at a specific time during the year. So this is what you usually hear about winter solstice and summer solstice. Summer solstice is June 21st of every year, and winter solstice is December 21st. We're looking right now at summer solstice. This would be 6 o'clock in the morning, 7, 8. See how the sun is moving. This is the 12 to 1 is when you actually are producing the most energy. And then we move on to 6, 7 at night. If we were to look at the same factors, but the analima is looking into other parts of the year. Winter solstice, as you can see, the path of the sun is a much southern prompt path. Therefore, the days are shorter. They start about 7 o'clock, and then they would move on to about maybe 6 o'clock or so. The amount of energy can be produced during those times, during this time of the year, is less. Now in Puerto Rico, the difference is that during those times we have very dry winters. Therefore, there's less cloud cover, so not as much of a difference in terms of energy consumption differences. And this here, I want to show you the actual design. These are the panels on top of the Boys and Girls Club facilities. We have the 12 arrays, about 103.5 kilowatts of power design on top of it. The pitch or slope on the roof is not that much to affect it to a point in which it might affect the irradiance factor, therefore the energy production. In the event that we see such an issue, we can always raise the racking systems so we can actually bring these panels to be a little bit flatter, looking up to the sun. Of course, always looking out in a southern, south um, orientation, as you can see here. Um, so this is the design. We're looking at about 103 kilowatts of solar. And now I'm going to go into the actual proposal that I'm sure that you guys have in your hand. I'm just going to go straight here into the glance of the system. We're looking at around using 5,952 square feet of 9,600 square feet of roofing space. That's 62% of the roof. That's going to give us 103.5 kilowatts of power, that we can put up there, or 227% of the daytime use in terms of what we can produce, and 237% of after hours use. So the system that we're looking to install should cover 227% of the energy needs during the day and 237% of the needs after hours. Why 200 instead of 100, 120? Very simple. Cloud cover, nuances, situations that may arise during the year. This is very typical of the market, that you should always look and design based on the 200, on a double basis, at least on the generation side. The amount of hours that we have to generate electricity in that region, in that area of the island, is 5.3 hours. That's the average. Sometimes we have 7 hours. Sometimes we have 4. So this is the average, about 5.3. Average hourly consumption for this building is 15.9 for about 7 hours. That's between 9 a.m. and 4 p.m. And then in terms of nighttime use, or the time that we're going to be using not the solar arrays to power the place, but the energy storage systems, that's 18.7 hours. Usually the average is 5.4 kilowatts, equivalent to about 100.7 kilowatt hours. So this is very important. We were looking into your own numbers. This is based on these factors here. We're looking at both buildings, BP1 and BP2, between 4 p.m. and 9 a.m. Building 1 is giving us 2.41 kilowatt per hour consumption, and Building 2 is giving us 2.94. This is based on numbers derived from this list. And then this, if you were to put this together, you're looking at 5.36. That's for us, is, we're rounded it at around 5.4. And then during the day, the hours of 9 a.m. and 4 p.m., that's only 7 hours. But the bulk of, the operations for the Boys and Girls Club, we have Building 1 consuming about 6.75 kilowatt per hour, and then Building 2 doing a lot more, about 9.16 kilowatts per hour. So you put those together, we have 15.92 between the hours of 9 a.m. and 4 p.m. Now this is very important, that we are looking to do an efficiencies assessment, particularly for the extracurricular area, the events area, the sports complex, where we understand that you are using halogen lighting systems. And it's important for us to look into the potential replacement of those systems, so we can actually then perhaps even enhance, to either enhance the pricing of this system, or enhance the reliability and therefore the availability of power for more use in the event that the property continues to grow in terms of more classrooms. The more kids you have, the more classrooms you integrate into your system, the more energy you will be consuming. Therefore, being prepared for the future is extremely important, and doing those efficiencies are a great way to not having to invest more in systems in terms of battery and solar, and just simply reduce your energy consumption despite your growth. So these are the two options. We are recommending to military grade or industrial grade, or commercial grade energy storage systems, together with a 103.5 kilowatts solar energy array. The first one will be Simplify Islanding Ready Modular System. This is a 112 kilowatt hour simplified lithium ion ferrous battery system. These are the same systems used by the military. These are great military grade um, lithium ion or lithium ferrous phosphate. This is very different from the typical Tesla batteries that you see in the market. Lithium ion cobalt is usually what's used in Teslas, and those run hot. They're not very efficient in terms of longevity, um, whereas in Simplifies can last up to 21 years. So, I'm sorry, up to 36 years at providing 100% efficiency. So this is the simplified solution. This is 40 of these batteries. The great thing about it is that it's very modular. It provides a it provides a it's a very modular system, meaning each battery is about 3.5 kilowatt hours. They're very small in size compared to other batteries in the market. And when we say it's modular, it's very flexible in the sense that you can actually just add a certain amount of batteries, and you can add more batteries as you move forward and you grow your needs, your business, and so on and so forth. The great thing about this batteries is that the expected lifetime of these batteries is up to 36 years, being used on a depth of discharge of 80%, which is the design that we have here. So if you use only 80% of the capacity of these batteries on a daily basis, they should last you 36 years before they start degrading below 80% efficiency. That's amazing in the market. So this is perhaps one of the best batteries, if not the best, in terms of a modular solution that can either go from 3.5 kilos to theoretically unlimited. So this is a product that we promote and suggest a lot to many of our customers. The solar system will be the same. In this case, we're basing our solutions on a 5.4 kilowatt nightly consumption, and that's for 18.7, I should say, not 18.3 hours of use during the night, and that's basically between 4 p.m. and 9 a.m. We're going to be basically that's our average for those times in terms of energy consumption is 5.4 based on the Excel sheet document that was provided by Boys and Girls Club. The system is consists of 40 PHI 3.5 lithium batteries, which gives us a total system of 112 kilowatt hours, which in this case will provide up to 111% of the necessary off grid hours, or nighttime hours of energy consumption. So we're 11% above the requirement. So we should be fine in terms of energy consumption during the nighttime. And then the second solution or option is the Blue Ion fully integrated off-grid solution. Same thing, we're looking at 103.5 kilowatt solar array. And in terms of our system, our battery system, the Blue Ion in this case, we're actually presenting a 112 kilowatt hour Blue Ion 2.0 lithium ion ferrous battery bank. Now, same technology, the same technology as the Simplify. The difference is the Blue Ion is a set of batteries that are actually conceived or placed inside a server box. And basically, it's an integrated solution rather than just individual batteries. Now, the being individual battery for the Simplify provides more of a flexible modular solution. In the case of Blue Ion, the real advantage is two things: is their warranty is second to none. The warranty for the Simplify is 10 years or 10,000 cycles. You're going to get to 10 years before you get to 10,000 cycles, that's for sure. But in the case of Blue Ion, it's 15 years or 8,000 cycles. And the reality is 8,000 cycles is 21 years. When you use this, you do a cycle per day. So this warranty is perhaps the best warranty in the market. Same technology as lithium ferrous phosphate, which actually runs cold. It's really efficient. And the beauty of these systems is that they can be charged by your diesel or gas generator. That's something that is built into our design as well, so that if you don't want to use PREPA in any way or form, and you rather use your generators, you can just run your generators for for about an hour or two, provide energy to the building, and then charge the batteries and provide yourself with another 18 hours of battery use. So you don't have to use that much diesel or gas, compared to if you were not having these systems installed. So again, same numbers: 112 surplus percent, 100 and sorry, that's 111% surplus, and we have 112 kilowatt hour blue ion 2.0 ferrous lithium ion ferrous system. We have inverters. We might be using Outback as well as SMA for this systems. Now the difference in price between one and the other is about $2,000. The warranty on the blue ion is really the kicker. So this is a comparison between them two. You see the price for the installation. Same solar energy array for both. For the blue ion, it's 350. Actually, these are not the right numbers. My apologies. 365 and 367. There you go. Somebody put the wrong number in there. That's 6, not 5. There you go. 112 kilowatt hours of storage capacity. Same for both. Scalability. Blue ion, you can actually scale it up to about 451 kilowatt hours, more than enough to cover your future needs. In the case of Simplify, it's basically unlimited. You can go as high as you like. The warranty is 15 years versus 10 years for the blue ion versus the Simplify. You can charge them both with a generator, and advantage for the blue ion, you can charge it within an hour with the generator, and the warranty in the case of Simplify is the flexibility, being a modular system where you can start small and continue to grow as you bring in revenues from your business. We're adding a energy consumption bonus program, which allows you to understand your consumption per appliance. This is a great tool for you guys to continue to make enhancements in terms of your energy consumption. This is something that we provide for you for free, and we can do it for one breaker panel. If you need to put more, to add more areas within your compound, then we can actually do that at a cost, at a discounted price. And we're the only ones doing that in the market today. This is warranties, 25 years for the photovoltaic systems. Simplify is 10 years. Blue ion is 15. And of course, a potential timetable scenarios, which are only approximates. Our terms of 75%. Do it signing. We can work this out. Bring that down, lower to another percentage, and this quote is valid for 30 days. As you see, we already provided you with the schematics, or at least the design. We can provide with the schematics so that we can actually work on the actual project management of the project, and hopefully this gives you a very good idea as to our proposal and presentation. These are the prices. We can work on the prices for you guys. Should be no problem. So you know where to find me. Hopefully this, again, gives you a good sense of what could be done. If you have any questions, feel free to call me, 787-710-5074. Thank you so much.